Okay, so we are working on today Proofs Worksheet 3. And like I said last time, I worked really hard to group them with kind of common proofs and common things so that we could get used to different groups at one time. So at the top of Proofs Worksheet number 3, it says this is segment and angle bisect and midpoint. So remember, if we go look at our Proofs resources, so if you see over on the segment side, definition of midpoint, it says right here that M is the midpoint of AB if and only if AM is congruent to MB. So it lets us say, if we know it's the midpoint, it lets us say the two parts are congruent. Same with segment bisector. If we know something is the segment bisector, it lets us say the two parts are congruent. It does not let us say equal, it lets us say congruent. Let's look at angles also real quick. So we're going to turn to our angle pages. So let's see here. Definition of angle bisector. If you know something is an angle bisector, then it lets you say the two angles are congruent. So remember, does not let us say equal, only lets us say congruent. All right, let's go back and look at this proof. So first of all, your given is AB and CD bisect each other at point M. And that's given right here. Then your next given, sometimes you have more than one, is MB is congruent to MC. So that's right there, and they wrote given. Okay, so the first two lines were just the givens. Easy way to start out the proof. Now, where we're headed is the proof. So AB equals AM plus MD. That's where we want to get by the end of this proof. So let's see what they said next. So next they said MC is congruent to MD. So let's look at where that is. So MC is right there, and it's congruent to MD, and that's right there. So if you look at line 1, it said the word bisect. It said AB and CD bisect each other at point M. So M is the bisector, so that means these two are congruent. And these two are congruent because it said they bisect each other. So when they say CM is congruent to MD, that's because it said bisect. Now that is a segment bisector, not an angle bisector. So if you look up here on the proofs worksheet, definition of segment bisector, if you know something's the segment bisector, then you can say they're congruent. Or if you know those two are congruent, then you can say that that's because of the definition of segment bisect. So this MC is congruent to MD because it's a bisector. So we're literally going to write definition of segment bisector, and we can abbreviate. Okay, so now let's look at line 4. All right, so we're over here looking at 4. I'm going to take out some of my highlights and things so we can just look at line 4 and figure out where it came from. So line 4 says MB is congruent to MD. Well, if you look, I always look at the line before, and I'm like, hey, what changed? So do you guys see here that MD was in line 3, and it's in line 4? Okay, so that did not change. It's still there. So what did change over here is MC is not there anymore. They wrote MB. So they can't just randomly change that. It had to be using substitution somewhere earlier in the proof. So let's go look for it. So right here on line 2, MB is congruent to MC, and on line 3, MC is congruent to MD. So you could either consider this substitution, or technically this could be the transitive property. So the transitive property, if you remember, if this is our first statement, MB is congruent to MC, that's line 2. Line 3 is MC is congruent to MD. Because these two are the same, you could cross them out and write MB congruent to MD. So that's the transitive property. If you were deciding to put substitution, though, I could absolutely see it also being substitution. Okay, so now let's take a look at line 5. So once again, we're going to try to see what changed from line 4 to line 5. So line 5 says MB is equal to MD. Okay, look back at line 4. The difference is there's no line segment on the top, and it's not congruent. Now it's equals. So literally it's the same thing. It just switched from congruent to equals. So what that is back on our general page, That's the definition of congruence. It is this one that lets you say if two segments are equal, then they are congruent. Or if two segments are congruent, then they are equal. So that's definition of congruence. Let us switch back. So we're going to put definition of, and you can put segment congruence, or you can just put of congruence. That's fine. Okay, so now line 6 is telling us, hey, you need the segment addition postulate. And it's making me wonder where I need it at. I'm not really sure because there's a lot of segments up there. So what I'm going to do is I'm going to look at line 7 and try to see, okay, where are we headed that I need this information? So do you guys see on line 7, it's AB equals? Well, I don't have any ABs up here in lines 1 through 5 other than the statement that it's a bisector. So it's AB equals. So that makes me think I should probably do the segment bisector with AB. So it's right there, AB. So go ahead and write down what would it be if you, segment addition. What would it be if you used the segment addition postulate to write a statement about AB? I'm just going to draw it up here so you can see it. So what would the segment addition postulate be for that statement? All right, so it would be AM plus MB equals AB, and that would be the segment addition postulate. All right, let's look at 7. So somehow we got from 6 to 7. So if you notice, we had AB, and so that's right here, and we had AM, that's right here, but instead of MB, now it says MD. So they must have swapped it out. So anytime they just swap one thing out, that indicates substitution. So you see what they did was from line 5, they took that MD and they substituted it into line 6. Because if MD equals MB, then you can swap them out for each other. So they used substitution, and they took line 5, and they plugged it in to line 6 for MB. Okay, and that's how they completed that. Let's go on to the second example. All right, so on proof number 2. The given, there's 2 of them. They're just written in a row this time, but that's okay. O is the midpoint of MN. Okay, that's line 1, and it says given. We're good there. And OM equals OW. That's line 2, and it says given. So far, they have it set up. It definitely makes sense at this point. I'm even going to go ahead and mark on my picture. OM is right here. Sorry, let me switch. Is right here. And it's equal to OW. So they're equal, but at some point, I'm probably going to need to be able to say they're congruent. So that'll come up at some point. But just for my frame of reference, I'm like, okay, those two, they're saying they're equal. So the next line, they say MO is congruent to ON. Okay, let's highlight those. MO, that's right here, is congruent to ON. That's right there. Okay. So now, somewhere above this statement in lines 1 or 2, there had to be a reason for us to be able to say that. We can't just pull it out of thin air. So let's look at line 1. Line 1 said, O is the midpoint of MN. Well, that definitely would be right here. O is the midpoint of this line. That absolutely would let us say the two sides are congruent because it said midpoint. So that tells me I'm going to use the definition of midpoint. And it's going to let me say the two parts of MO and ON are congruent because of definition of midpoint. Okay, so now definition of congruence can let us move something from congruent to equals or equals to congruent. So now we have to decide which way we want to go. When I'm stuck, I look at the proof and I'm like, okay, where am I headed? So if you look at the proof, I'm headed to OW equals ON. So that tells me I probably want everything in equals, not in congruent. So let's take line 3 and let's rewrite it as MO equals ON. So I didn't change anything except I went from congruent to equals, and that is what the definition of congruence lets us do. Okay, so now the symmetric property just lets us say, hey, MO, which is right here, is the same as OM. It's exactly the same space, just the order of the letters are reversing. That's the symmetric property. So they stated that because I think we'll get to switch it out in just a minute here. So now on line 6, they said, hey, we're going to use substitution next. And they're doing line 5 into line 4. So let's see what they're talking about. They took something on line 5 and put it in line 4. So since line 5 and line 4 both have MO in common, I'd say that's what they're switching out. So they're taking OM and they're saying, hey, that's the same as OM. And they're plugging it in right there for MO on line 4. They're swapping it out, which is substitution. So that means instead of MO, they're writing OM. And they still have right here on line 4 equals ON. So OM equals ON, and that was substitution. And that was just to get the letters written in the correct order to get to our last statement. Okay, line 7, OW equals ON. All right, so somehow we used OW and ON. So if you look at where that happened, and I know the highlighting gets a bit crazy by the end, but we got this. If you look at where that happened, here is where we have ON, and here is where we see OW. So somehow they combined lines 2 and line 6 to get to line 7. So let's look at what happened. So they knew on line 2, OM equals OW. And on line 6, OM equals ON. So basically, they could take this OW, and since it equals OM, they can swap it out for that OM. They can just do a trade. That's substitution. So they just put the OW right here instead of OM, and they still have equals ON. So they swapped it out, or they substituted it in. So it's substitution. And they took it from line 2, and they put it into line 6. And that's how they gave us line 7.